So we'll talk about the protection of data within your Redshift instance here in a minute. But now that we've covered physical security provided by AWS and the shared responsibility of your instance security, let's talk right now about protecting data in transit. Data as it comes into your Redshift instance and data as it leaves your Redshift instance. When loading data, we've covered the numerous file types that Redshift can natively load: JSON, delimited, text files, Avro, and other types. Many of these may be fully plain text, meaning if they were intercepted en route, sensitive data could be at risk. For this, Redshift allows encrypting of files intended for loading via S3. This encryption can take several forms, the first being server-side encryption. In server-side encryption, S3 encrypts the data as it's received, stores it encrypted, and then unencrypts it as it loads into Redshift, a typical encryption at rest approach. Any other access or interaction is completely with encrypted data. You enable this by simply requesting S3 to encrypt by use of an encryption header in your REST API call, which then implies that you'll need to use the REST API, or at least the SDK wrapper for the API when coding your upload of files to S3. This is fairly trivial, however, and code samples abound online. With that said, you can also request this through the AWS Management Console when uploading single files manually. Now, there is no additional syntax needed in the copy command as long as you have the rights to access the file. As soon as you initiate that access, S3 decrypts it on the fly. Another approach is client-side encryption. In this approach, you encrypt the file before it ever leaves your control, long before S3 ever sees it. This is sometimes called envelope encryption. Now, the critical thing to understand here, however, is that this means you are 100% responsible for management and protection of the keys used to create the encryption. If you lose the encryption key, there's no way that AWS or Amazon can decrypt your data for you. So you need to have a robust storage and disaster recovery scheme in place for management of your own keys. Now, luckily, there's lots of key management services and key management products out there, including even one in AWS. Now, when it comes time to load the file using the copy command, you simply provide the necessary key information as part of the copy command. There's just two additional parameters as seen here. You provide the master key and let it know that it's encrypted. Now, the strength of this approach is that the file is encrypted not only at rest on S3, but also as it loads into Redshift and as it travels from the original source to that S3 bucket in the first place. Server-side encryption doesn't offer this level of protection. The data traveling from its original source to that S3 bucket is potentially unprotected. Now, the same problem is potentially present when querying data that's already loaded into your Redshift instance. The plaintext results of a query travel across potentially unprotected wires and signals. So the answer to both problems is SSL, the same basic approach to securing sensitive data that you exchange with many other websites and services. SSL certificates are installed by default on the cluster and fully supported at the client as long as you have the latest Redshift ODBC and JDBC drivers. Now, if you don't, visit this link for more information on ensuring that you can take advantage of SSL. The associated certificates can also be downloaded if you need to explicitly add them as trusted certificates on your own system. Now, SSL on the cluster side is always enabled, but by default is not required. In other words, if the client requires it and specifically requests it, SSL will be used. If not, well, it won't. On the cluster side, to change this setting and make SSL mandatory, you simply need to modify the parameter group associated with your cluster. You can see that here. You have a default parameter group, but this one isn't available for editing, which simply means you just need to make a new one, put in your additional changes, and set it as the related parameter group with your cluster. Now, there's two settings with SSL. One that says SSL is required, meaning any connection with your Redshift instance will only be over an SSL connection, and the other has this FIPS keyword. This is a federal standard, so if you know what FIPS is and you know that it's mandatory for your use, you can enable that here. If not, the recommendation is don't use it because it's additional overhead that you may not need. Now, in our demos that leveraged ODBC, SSL was actually already being used as the setting on the ODBC driver was set to verify CA, verify certificate authority, as you can see here. So even though SSL wasn't explicitly mandatory on the cluster side, it was being used because it is specified as mandatory on the client side. Now, knowing when your connection is encrypted isn't always clear when you have a setting on either side. But AWS has a handy chart within the Redshift documentation that shows the condition of SSL under all configuration options. You can see that by going to this link here. Now note that the URL for connection documentation also has information for the JDBC drivers. Now the SSL that we've been demonstrating protects data between your client and the Redshift cluster. Going back to our original in-transit problem, encrypting data that you've uploaded to S3, destined for Redshift, but under a server-side at-rest encryption scheme, you still need to protect that data as it travels from the original source to S3. So for this, you'll need to establish SSL within your code for the upload of files. And again, all of this is very well documented in code samples online. Now in the little graphic we've been using here to demonstrate where data is protected in transit, there's one additional item I'd like to point out, and that is within the AWS cloud, Amazon Redshift uses hardware-accelerated SSL to communicate with Amazon S3 or Amazon DynamoDB. And this is for copy, unload, backup, and restore operations. Meaning this is all handled behind the scenes, so you don't really need to worry about protecting your data on the wire when it's within the AWS assets, your network, or the VPC.